Hello, my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. So, welcome to NEET one-shot sessions here. Today, we're going to discuss about the thermodynamics. So, please confirm you're all able to hear me, can see me. I want the confirmation in the chat box very quickly. Very quickly. How are you all? So, you are in the ramp of preparation of NEET examination. So, in this series, we completed general organic chemistry, hydrocarbons, chemical bonding. Now, we are slowly entering into physical part of the NEET examination preparation, thermodynamics. So, let us follow the strategy of NTA. They are giving a paper in such a way that it is connected with all questions as far as the chemistry is concerned from thermodynamics. So without thermodynamics connected questions, you don't get the paper. So directly you are going to get two questions from this thermodynamics. So it is directly one and or indirectly one. So what are the topics that we are going to discuss in thermodynamics? Let us see here. Before going for that, a small capture. So oath of the day. So let us prepare NEET examination by taking a oath. Crack your NEET examination simply preparing yourself sincerely by taking a pen and paper. Attend our classes without any fail. We are going to give you very important tips and tricks. You all make a note of it and we do it. And please like our session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. And of course, in the Google App Store, you can see Infinity Learn app where you're going to access live classes, mock test, create your own test and 24 by doubt resolution sessions. So these two are, you can see here, create your own test. Whenever you are preparing for something, if you have any kind of doubt in a particular topic, you can create your own test for extra support and you can have that assessment and also any doubt anywhere, just it is one click away. That is 24 by doubt resolution session. So it is powered by artificial intelligence. Okay, anyways, when you are preparing for any examination, it is required to understand where exactly you stand and what is your improvement areas, what is your strength. For that you need an assessment platform. Infinity Learn scientifically designed an assessment platform that is all India test series for the NEET preparing 2025. You want to see yourself like this by holding a stethoscope. Yes, we can provide you that environment for that. So benchmark yourself against India's best assessment platform by the Infinity Learn. Enroll now, which contain this test series contain 34 full syllabus tests. In that 14 grand test, 20 mock tests are available. And actually this cost around 6,000 rupees. Now 80% discount you are going to get, for that is 1,200 rupees. The problem, you have to enter the coupon code YT80, so that automatically the price is going to come down. It is going to be very good opportunity. So 1,200 rupees is not a big deal. So everybody, in the description box also, and in the pinned messages also, the link is available. You can click it and you can enjoy it, right? So my promotion is over. Let us start thermodynamics. So please tell me how many of you are comfortable in thermodynamics and how you are improving in thermodynamics. So what you are going to learn in today's class? You are going to learn every point in this thermodynamics, which includes first law of thermodynamics. I don't want to stay like it is state and a system, open system, closed system and isolated system. That's simply a time pass. I don't want to do that. So in this NEET examination, you are already completed the syllabus and you want to recapture in one shot, my dear students, first law of thermodynamics. You study about the entropy, spontaneity, and eventually we enter into thermochemical equations and Hess law of constant heat of summation, and you have thermochemical calculations as well. So the most important point as of this thermodynamics is concerned, you have first law of thermोडायनामिक्स डेफिनेटली उन क्वेश्चन आपको फिजिक्स में भी फायदा उठाने की कोशिश करो इसके लिए and you have criteria of spontaneity related to the Gibbs free energy and also thermochemical equations. So definitely one question directly asked from here. It is connected. Thermodynamics is connected to all physical chemistry part as well as kinetics, equilibrium and everything. Hi, Sangaram Dorge. So you want to be see entropy, you want to give a more emphasis, definitely I will give some. Second law of thermodynamics is based on entropy and first law of thermodynamics is based on enthalpy. So ready everybody, one give me a thumbs up and fair emoji, we will start the class. So these are the topics that you are going to discuss in today's class, and I can guarantee you at the end of today's class you are going to get an awesome feeling and a good confidence in thermodynamics and get well prepared for your NEET examination. Why late? Let's talk about the first law of thermodynamics. In that you have various terminologies. The energy in the process may be transformed from one form to another form, but it neither be created nor be destroyed. Okay, and somebody name I can't read it out because the name is written in a different script. I don't know that script. Okay, so you cannot create or destroy energy, but one form of energy can be converted into another form. In any process, the sum of energies of the system and surroundings is always constant and the total energy is conserved. Law of energy conservation is related to thermodynamics for any given process. Okay, so I just want to say energy neither be created nor be destroyed, but energy can be transformed from one form to another form. This is one version. We have 20 different types of definitions. So let me read out some kind of definitions. If certain quantity of one form of energy is disappeared, same quantity of another form of energy should appear, or otherwise the equivalent quantity magnitude of the work should be done. So these are the various versions. You are virtually you have to feel it and you have to understand it is given as a mathematical versions, right? And let us talk about what is the mathematical version of this first law of thermodynamics. First law of thermodynamics rules out the existence of a perpetual motion machine of the first kind. What is that? It is said that it is impossible to construct a machine, a perpetual machine which can work continuously without supply of continuous energy. So it should be supplied energy, otherwise the machine don't work. Okay, so otherwise you can say first law of thermodynamics is known as law of conservation of energy, and the mathematical form is given as delta U is equal to Q plus W. What is this? I'll tell you. Okay, so this is a system, my dear students, this is a system. It has an internal energy, let us say state U1. Now this is given to some amount of Q and simultaneously some work is done. Simultaneously some work is done. ताकि इसका एनर्जी U2 बन गया है ना. So this is the initial state and this is the final state. Rather I would say energy so initially कम होगा, finally ज़्यादा हो सकते हैं. Okay, let me write U1 here, U2 here, doesn't matter. And there are certain things. Priyanshu, good afternoon. Good afternoon. How are you? So the final internal energy U2 is equal to U1 plus Q is given and W is work is done on the system. I want to take this U1 in that side. So U2 minus U1 is equal to Q plus W. So U2 minus U1 final minus initial, it is going to be delta U. So that delta U is going to be Q plus or minus W. What is this again? So this is what is called as the first law of thermodynamics. If heat is, this sign conversion is very important. If plus Q is given, heat absorbed, heat given in, okay, minus Q, heat given out of the system. Are you getting or not? Clearly see. So whenever certain complicated things are there, you just break it and learn small simplified things. Priyanshu, agree with me? And I wanted to say, if W is given as a negative and W is given as positive, so it is work done by the system, it is work done on the system according to chemistry IUPAC. Physics में थोड़ा सा उल्टा दिखता है इसका. And I want to conduct a special class how to solve the questions from physical chemistry. So simple mathematical version. Okay. So you need not have to give the big calculation versions and all. It is not at all supported, right? So Priyanshu, fine. And Sangram, hi. Now let's talk about the IUPAC conventions. That's what I wanted to say here. Everything is mentioned here, and a simplified version. Heat absorbed by the system or work done on the system is always positive. On the system is positive. Physics में work done on the system negative दिखता है, so physics में अलग conversions होता है. So now we are not going to debate the why it is there like that in physics, why it is there in the chemistry like this. So we are going to follow the question paper given by NEET examination by NTA. NTA follows CBS and IUPAC standards according to chemistry. Work done on the system positive, work done by the system is negative. So let us follow that. Okay. Now let's see here. Heat given by the system or work done by the system is negative, right? So you have to follow, have to strictly follow. The problem comes here, it is when you use the positive and negative and solving the first law of thermodynamics, it gives a lot of emphasis, and this gives a lot of confusion. And take care of the sign conversion and solving the questions from the NEET examination. Now if heat is absorbed by the system and work is done by the system, U is equal to plus Q minus W istemal karo. Okay, and the same thing otherwise, if the heat is absorbed by the system and work is done on the system, W is positive, delta U is equal to Q plus W, right? So it is very important to use it. Sometimes plus 100 kilojoules of heat and 50 joules of work is done by the system, you say. You have to use minus 50 or plus 50. So you take the magnitude as it is and you use the sign conversions. Okay. And talking about if the heat is liberated by the system, work is done by the system, that delta U is equal to minus Q and minus W. Are you getting or not? Take a pen and paper, everybody work along with us and you will understand how it can be done, right? And it is ready-made, and it is scattered, and everybody write it, and undoubtedly you are going to do the best in your NEET examination, fine. And similarly, if heat is liberated by the system and work is done on the system, delta is equal to minus Q and plus W, right? So everything is clear. If any doubt, you please let me know. Use the chat box generously and you can discuss any topic related to the chemistry. Okay, my dear students, here if heat changes in a system can take place at a constant volume, at a constant pressure as well. So at a constant pressure, you can say dP is equal to 0, and constant volume, you can say dV is equal to 0. If dV is equal to 0, this is called isochoric process, and dP is equal to 0, this is called as an isobaric process. And what happened if dt is equal to 0? If dt is equal to 0, put in chat box if dt is equal to 0. Okay, we'll do numericals also. Let us not go with integrations and all. Okay, so I give more emphasis, more and more emphasis in solving numericals in today's class. Okay, and what happened if the process is carried out the constant volume, no volume mechanical work is done, since V is constant, then therefore dV is equal to 0. This is isochoric process. This is called isochoric process. Fine. And also you can say, hence PdV is equal to 0 and work done is equal to 0, because as we know, work done is equal to minus P external and change in the volume. Okay, if this value is 0, this is going to be 0. Application of first law of thermodynamics. And also you can say from the first law at constant Constant pressure means isobaric process. If the work is done, is pressure volume work. The work done is denoted by PdV. That's what I mentioned. W is equal to minus P external and delta V. It depends upon different processes. Okay. It is a reversible process or irreversible process. In the irreversible process, you can use this. If it is a reversible process, you can use minus 2.303 ln V2 minus V1. Okay. Isothermal means no change in the temperature. No. Isothermal means dt. Okay. dt is equal to 0. That's good. I appreciate. And dq is equal to 0 is adiabatic. There is a confusion between isothermal and adiabatic. Okay. Right. If the heat is not exchanged, it is heat constant. So it is called as adiabatic. And if heat is entering and coming out, so that the temperature is going to be constant, that is called isothermal process. Okay. And I just want to say, therefore, the first law of thermodynamics for isothermal process, it is called isobaric process. You can say delta U is equal to QPdV. Okay. And it comes to be the same way what we discussed. QP is the heat absorbed at constant pressure. Okay. That is given as a enthalpy. Okay. So let's see that also. U plus excuse me, U plus PV is called enthalpy. It is denoted by H. So if we want to discuss this enthalpy in the simplest understandable theoretical way, so heat, we discuss the heat. Internal energy is given as U. That is nothing but heat at a constant volume. So most of the processes that are taking place around us in the universe is again the constant external pressure. So all natural processes taking place like that. For that you need enthalpy, that is called heat constant, heat at constant volume, constant pressure. So how these two are related? Okay. So these two are related. Enthalpy is equal to internal energy only, but something is PV work. It is said to be PV work. So PV is equal to nRT, PV work is equal to P delta V, and PV is equal to nRT, P delta V is equal to delta nRT. Delta N is the number of moles during that process that is going to be changed. So that is how it is related. H is equal to U plus PV, PV work done. So if the QP is equal to H2 minus H1 and delta H, then U and P are the state function. The functions, the properties which depends on the state, which decide the state of matter, are called state functions. Okay. And H is also a state function. H is also a state function. And delta H is equal to change, delta H plus P delta V, and P delta V is equal to delta nRT. Based on this, you are going to get a super important questions, my dear children. Okay, studying thermodynamics require little bit of application in general. Okay, so we are here, no worries, we will help you out of it. Stay tuned, don't leave the session, and take a pen and paper and write along with me. Definitely your knowledge, if you don't know, you will learn. If you already knew, it will be organized in your mind. So the outcome is going to be, you are going to do super awesome in your NEET examination. Believe us, definitely, especially for the students who are preparing for NEET examination, thermodynamics, chemical kinetics, electrochemistry, and these are the kind of direct equilibrium also. It is going to be little difficult and nightmare or fiery chapters. So no worries, we are here to take care of you. We will give you the best of it, and come on, stay tuned and write all the things. So delta H is equal to delta U plus delta nRT is going to be the super important formula. Delta H is equal to change in enthalpy, and delta U is equal to Change in internal energy, R is the gas constant, T is the temperature, my dear children. Here I just want to say what is delta N. Delta N is the difference between the sum of the number of moles of the reactants minus sum of the number of moles of the products. So what happens if delta N is equal or greater? Okay, there are three cases where delta N is equal to 0. If delta N is going to be greater than 0, if delta N is going to be less than 0, इसका application क्या होगा? So we can say here example, H2 is combined with I2, which is in the gaseous state, gives rise to HI, which is in the gaseous state. So इसका delta N क्या होगा प्रियांशु, संग्राम? Okay, so delta N is equal to 2 minus 1 plus 1 is equal to 0. इसका delta N 0 होगा. So delta H is equal to delta U plus delta nRT. Okay, so इसका value 0 मान लो. So ताकि ये 0 into RT is equal to 0 होगा बेटा. So that we can say it is going to be delta H is equal to delta U. So this is the outcome of this. And और एक example मेरे साथ है. Only gases you have to say. PCl5, which is a gas, is giving rise to PCl3, which is a gas, plus Cl2, which is a gas. So I wanted to say delta N is equal to 1 plus 1 minus 1 is equal to plus 1. Okay, as this delta H is equal to delta U plus delta nRT. Okay, मान लो ये वाला प्लस 1 का है. So that delta U ये RT वैल्यू मिलके delta H होगा, ताकि इसका आपका delta H is greater than delta U. So that we can say in this case this is the true. Agree? Now you will be asking a question. So heat at a constant pressure, heat at constant volume, and let me give you the example also, and I'll give you how the question can come. So let me give you the N2 is a gas combined with H2 is a gas and gives rise NH3 is a gas. Let me balance this. इसका delta N क्या होगा? It is 2 minus 1 plus 3 is going to be minus 2. When it is minus 2 now, okay, when it is going to be minus 2 now, it is going to be delta H, delta U minus delta plus delta nRT. मान लो ये वाला minus 2 का है, डेल्टा H ज़्यादा है, सो इससे ये वैल्यू सब्ट्रैक्ट करने तो ये इसका बराबर होगा, सो दैट ये वैल्यू बहुत ज़्यादा है. सो अंडरस्टैंडिंग मैथमेटिक्स, डेल्टा H is less than delta U. Okay, now how the NEET examination can come? So look at this. In this you are going to have delta H minus delta U is equal to delta nRT. Understand or not? So you will be asked what is the difference between heat at constant pressure, heat at constant volume. That's very, very important. That's very, very difference. They don't use any term other than difference between heat at constant pressure and heat at constant volume. Agree? Understand? And also, if delta H is given, you are asked to calculate delta U. If delta U is given, you are asked to calculate delta H. अरे ये डेल्टा H डेल्टा U वैल्यू दोनों बराबर देखते, सिंपली गैस कांस्टेंट जब आप थर्मोडायनेमिक्स में जो भी प्रॉब्लम आप सॉल्व करना चाहता हो, 8.314 जूल केल्विन इनवर्स मोल इनवर्स इस्तेमाल करो. ओके, माइंड इट. सर 0.081 कब लेना है सर? That is taken somewhere in the Dalton's law and the states of matter and osmotic pressure in the chemistry. And apart from that, you have to take the R value in 8.314 joule Kelvin inverse mole inverse. समझ में आ रहा है क्या my dear children? So I am feeling my students are very good, smart, intelligent, hardworking, but you are little confused किस चीज़ कहाँ इस्तेमाल करना. So you have collection of n number of confusions. Here in one shot sessions जब चल रहा है ना, it is my responsibility to remove all, okay, clear all your doubts. Agree? Clear all your doubts. So one thumbs up and fire emoji in the chat box so that I will get connected with the students. Okay, it is not a radio telecast session, my dear students. Rather, I would say it is a live interactive session. I would be very happy if the students are connected with me. Okay, and आगे बढ़ते case 1, case 2 भी है, case 3 भी है, and case 1, case 2. अभिषेक राज फायरी चल रहे. Very good. Good afternoon बेटा, आप कैसे हैं? Okay, so types of reactions. So we are into types of reactions. Okay, slowly we'll discuss about the concept of spontaneity and the entropy also. And at 1 hour we are going to take a short break of 5 minutes, then we can go with one more session extended. And you have an exothermic reactions, you have endothermic reactions. So exothermic reactions means heat is released. Heat released. Okay, endothermic reactions mean heat absorbed. Heat released and heat absorbed. है ना? Now I just want to say A plus B gives rise to C plus X kilojoules of heat. Carefully you see how this is written. It is not a thermochemical equation. A plus B gives rise to C and delta H is equal to minus X kilojoules. So that is the appropriate way to show thermochemical equations. So जब आपका exothermic reaction आता है ना, so delta X is going to be, delta H is going to be negative quantity. Abhishek Raj, okay, Priyanshu. Now when A plus B takes X kilojoules of heat, okay, and gives rise to C, so heat is absorbed. You can say A plus B and gives rise to C, इसका delta H होगा आपका plus X kilojoules. That is very important. That is very important. Okay, enthalpy of reactants and products. Reactants का enthalpy इसका ज़्यादा होता है and products का energy इसका ज़्यादा होता है. Okay, so talking about the entropy. So I don't, it is a one short session, बच्चों. I don't want to give much more about anything like granular level of discussion, but every point we are going to discuss here, right? 1 minute. Yeah, what is an entropy? Hi Jitendra, ये ग्रेड 11 का टॉपिक है बेटा. जितेंद्र, we are discussing here about the NEET examination preparation, and this session is super important for those preparing for your NEET examination or whatever the examination, and also those who are in the grade 11, and the grade 11 the thermodynamics is there, and who are in the grade 12 also the thermodynamics concepts should be applied, and those who are dropped and preparing for your NEET एग्जामिनेशन इन लोगों का भी ये चैप्टर बहुत फ़ायदा होता है. So talking about energy, entropy and second law of thermodynamics. Entropy is a thermodynamic state function which describes about the degree of randomness or the freedom. You can see the gas state here, high randomness and highly disorganized. Let us keep these things little closer, they are static now, and they are going to be compactly packed. You can see the way they are arranged is going to be so compact, less random, well organized. So the entropy is a thermodynamic state function which measures the degree of randomness. More is the randomness, more is going to be the entropy. Okay, now we can say what is entropy? It is a measurement of the degree of randomness of an energy in a system, Okay, and the lower the entropy, more is ordered, organized, the particles present in the state of matter is going to be organized, and less randomness, and it is the vice versa. You can see highly disordered and highly organized, less disorganized, more disorganized, है ना? हाँ, Jitender, wanna say something? Abhishek Raj and Priyanshu and Sangram, come on. And here I wanted to say a gallon of gas, prepared food and sunlight have low entropy. Okay, and when these are used, their entropy increases like this, you know. So let's see, low entropy, low disorder, more entropy, more disorder. Okay, disorderness, ये कैसे calculate कर सकते हैं? Yes, by using second law. Entropy is a measure of disorderness of a randomness of a system. It is denoted by S. Okay, and entropy is a state function. It is an extensive property. You see how granular level the questions can be given in the thermodynamics. Okay, and entropy of a substance is lowest in a crystalline state and highest in the gas or vapor, right? And the order of entropy for a substance in the gaseous state is always greater than, the liquid state is always greater than a solid state. Okay, and the difference between the enthalpy and entropy, it makes a lot of confusion in the students. Okay, you can see the enthalpy over here. So enthalpy is measured, shown by using H, and entropy is shown by using S. Okay, getting or not here? Enthalpy is denoted by H and refers to the measure of total heat content in a thermodynamic system under constant pressure. That is the condition. While the entropy is denoted by S, refers the measure of a level of how thermodynamic disorderness is seen. Right? So when this has some heat, let us say a cube of ice, it has in the solid state, and it is melt, it give rise to a liquid state. So it is going to increase, absorb the heat, ताकि a solid state, a बर्फ जो है ना, this is going to be molten to give its liquid state. So it is an endothermic process. ये process से जिस direction में delta H endo होगा, delta H positive होना चाहिए, and where this solid is going to be well organized state, when it is molten, the particles are going to be disorganized. So entropy is going to be increased and enthalpy is going to be increased. Okay, there is no condition like whenever entropy increases enthalpy should also increase, which is not actually a correct statement. Okay, and let us say basic terms and an entropy and enthalpy. You can see how we are handling this entropy and enthalpy in the thermodynamics. Okay, uh, basic terms meaning it is a measure of randomness is the entropy, it is the measure of randomness is the entropy, and constant pressure, the energy at constant pressure, heat at constant pressure is going to be enthalpy. That is the major difference. Logically it is a major difference. Okay, now let us talk about what is the units. Enthalpy values is joule mole inverse and joule Kelvin inverse. Actually it is given kilojoules में भी दे सकते हैं. Okay, generally these values are kilo, joules and mole inverse. Okay, here K stands for Kelvin beta. It is Kelvin temperature because it is a Q by T. So enthalpy, you can say enthalpy change is equal to Q by T. Okay, it is in joules and it is in Kelvin. Okay, now entropy, enthalpy can be calculated delta H is equal to delta U plus P delta V. We have already seen that, right? So carefully you see how nicely the thing is going on. The nature, it's a property. Enthalpy and entropy is a property, and entropy is a kind of energy. Okay, it is not an entity and it is a kind of energy. And abbreviation S and H discovered by Clausius, and it is discovered by Heike. And system favors always system favors its entropy to be minimum entropy, sorry, maximum entropy. System always favors to get the minimum enthalpy. Okay, system always to get a minimum enthalpy and a maximum entropy. Okay, so this is the basic terms you need to know about the entropy. And let's see for the entropy for the second law of thermodynamics. So I just want to say, first I'll go to the second law of thermodynamics and I'll come back. Entropy of the universe increases in all spontaneous reversible process. Okay, entropy of the universe increases. So entropy of the system between any two states of a same substance at equilibrium is given delta S is equal to Q reversible by temperature. Okay, and also I just want to say enthalpy of entropy of a system and entropy of a surroundings एंड दोनों मिलके ये 0 से ज़्यादा होना चाहिए, and always is going to be positive, and this is what is called as second law of thermodynamics. Okay, and I just want to say here, if the process occurs with a change in temperature, then to calculate entropy change delta S is equal to sum of the change in the heat at reversible process upon temperature. And also you can say absorption of heat by the system leads to an increase in kinetic energy, of course. So whenever kinetic energy is increased, kinetic energy is directly proportional to the temperature. अगर temperature बढ़ते जाएंगे तो kinetic energy भी बढ़ते जाएगा, entropy is going to be increased. So absorption of heat at low temperature develops more disorder than at high temperature. It is going to be super important, and I will tell you how it is. Okay, so for absolute entropy values from the solid to liquid and the liquid to gas, and entropy change from here to here is going to be more. Now you can see when the system changes from solid to liquid, now that is what is called as the melting point. When the liquid changes to liquid to gas, that point is called as the boiling point at the temperature. So these are the temperatures by virtue of definition you need to know. Okay. Now I can say the unit of entropy I already mentioned, that is joule Kelvin inverse, and the unit of molar entropy joule mole inverse Kelvin inverse. Okay. And for a spontaneous process, delta S total is greater than positive for irreversible spontaneous process. A process spontaneous का मतलब क्या? I'll come back. Okay, for a non-spontaneous, the जो process आगे बढ़ते and the process होगा, and that is called as a spontaneous process. जैसे process आगे नहीं बढ़ते, okay, जैसे process नहीं होगा, that is called as a non-spontaneous process. Okay, now at equilibrium delta S, of course anything is going to be zero. That's very important. And entropy change and the reversibility of the process. Okay, I want to come back to this once again. I wanted to give you, use the chart box everybody, a logical question. Now something strike it in the mind. Let us discuss that, what's wrong in that. My dear children, let us take a system here. My dear children, let us take a system here. This is a system. This is a system A, and this is another system B. So it contains an ideal gas, same temperature, okay, same quantity, same volume, same pressure, everything. It contains ideal gas. Okay, carefully you see. And it has some entropy, that is called entropy SA. Okay, and it has an entropy SB. Now the temperature of this is going to be 0 degrees centigrade, and this temperature is going to be 50 degrees centigrade. Okay, now whose entropy is more? You tell me, whose entropy is more? Whose entropy is more? Yes, of course, at that situation 1, at that situation 1. So it is a state 1. Okay, it is a state 1. At state 1, entropy of B is greater than entropy of A. है कि ना? जैसे टेम्परेचर इसका ज़्यादा है, एंट्रोपी जी बढ़ना चाहिए, है ना? Now I just want to take this system into the state 2. Thermodynamics prepare करना का एक स्टाइल आना चाहिए. I wanted to show you the best out of it. You will understand super important thing here. Dear children, इसका 10 joule energy add किया, heat 10 joule add किया, simultaneously, okay, heat इसका 10 joule add किया जाएगा, okay, ताकि इसका एंट्रोपी बढ़ जाएगा, इसका भी एंट्रोपी बढ़ जाएगा. कितना तक? So yes dash B बन गया, okay, and इसका yes dash ये बन गया, है ना? yes dash ये बन गया. Now मैं क्या पूछना चाहता हूँ आपके लिए, this is called state 2. This is called state 2. This is called state 2. Okay. Now ये जो अंतर है ना, देखो ये जो अंतर है ना, that is called as delta SA, and this is called delta SB. And I want you to ask as far as the NEET examination questions are concerned. Okay, yes, NEET examination में delta SA is equal to delta SB. delta SA is greater than delta SB, and delta SA is less than delta SB. Okay, so only three options are there for this question. I want you to give the answer for this question. Option A मान लो, option B and option C. Dear children, so such a beautiful explanation. You tell me what is the answer for this question. I am expecting the answer in the chat box from everybody. So dear students, please give the answer. So such an important understanding exercise I just want to give you. Okay. You want to say B? अभिषेक राज, जितेंद्र आप भी बोल सकते हैं ना, प्रियांशु, संग्राम and all the students, Anushka Roy and Triveni Roy, Suresh Kumar, these are all my regular students, hidden gems. Abhishek Raj, ha, Sarika Singh, hi. So I acknowledge everybody, Sarika, ये तीनों ऑप्शंस का आपका आंसर क्या? I am Dr. Suresh, Faculty of Chemistry, Betty. Sarika, come on. Answer. Expecting an answer from you. You want to say C? Okay. So, ये 0 टेम्परेचर 0 डिग्री सेंटीग्रेड से ये 10 जूल्स एब्जॉर्ब कर रहे हैं ना, ये 50 डिग्री सेंटीग्रेड से 10 जूल्स एब्जॉर्ब कर रहे हैं. ओके, अलग अलग कंटेनर्स में एक ही वक्त में दे रहा. ओके, क्या चल रहा है यहाँ पर? सर, जैसे ये सिस्टम इससे कम टेम्परेचर से एब्जॉर्ब ज़्यादा कर रहे हैं ना, इसका एंट्रोपी चेंज ज़्यादा होगा. दैट इज द रीजन वाई डेल्टा एस इज गोइंग टू बी क्यू बाई टी. चेंज इन एंट्रोपी, जिस टेम्परेचर जैसे कम से कम है, इसका एंट्रोपी ज़्यादा है. So I would say my answer for this is going to be option B. Are you getting or not? So this is a very important, my dear children, right? Now look at this. I wanted to say absorption of heat at low temperature develops more disorder, point number 8, than at a high temperature. Clear? Just go through this random example that I already discussed with you. Come on. And we'll discuss some more concepts, my dear children. So I just wanted to say here, entropy of the inverse increases for a non-spontaneous process, and absorption of heat by the system leads to the increase in the kinetic energy, and also absorption of heat at low temperature develops more disorder than at high temperature. Okay, and this already we discussed. Okay, units also discussed. For the delta S is going to be positive, and also given delta S is always positive for the non-spontaneous process. Okay. Yes, we'll discuss more. This we discussed. Yeah, for what is a spontaneous process? The criteria of spontaneity. Process, the process which go by itself by proper initiation or without proper initiation. Such a process is called a spontaneous process. So when this rock is rolling down the hill, okay, this stupid boy has no safety concerns. That's why he is standing here. So if the rock roll over here, na, he will get accident, na? Yes or no? So this process you can't stop it. It is proceeded by virtue of the nature, right? By virtue of the nature, right? So when you talk about the process which may take place by itself after a proper initiation is called as a spontaneous process. And a spontaneous process may take place instantaneously or may be a slow. Speed you can't decide it. Okay? इस वक्त में it is so dangerous. Agree? Sarika? And what is a non-spontaneous process? A process that do not takes place by itself. It's not at all feasible. A process nahi hoga. And example, flow of water uphill. पानी ऊपर से नीचे आ सकते हैं, नीचे से ऊपर नहीं जा सकते हैं ना स्पॉन्टेनियसली. आप मोटर इस्तेमाल करना इस चीज़ के लिए. ओके, flow of heat from colder body to hotter body. You can see, dear children, when you see a system over here, when your system is given, when you see a system over here, so it is a hot body and it is a cold body. The heat is going to be move always from hotter body to colder body. That is possible. And the reverse is not possible. अब reverse करने के लिए क्या चाहिए? आप air condition में, refrigerator में वही चलता है. So we have to use a machine to do its work. Understand? And also a rolling of a rock downhill is a spontaneous process. And the rock eventually comes to equilibrium at the bottom of the hill. जब ये this is coming down and staying here and it is going to stay equilibrium. Okay, and when this is pushed, actually it is not spontaneous. The rolling of a rock uphill is a non-spontaneous process. समझ में आ रहा है क्या, my dear students? Clear? This is a process is called a spontaneous process. This is a process in this direction. In this direction is called as a spontaneous process, and in this direction it is called as a non-spontaneous process. Are you getting or not? And you can say, when this is a gas and this is a vacuum, and it is connected to a tap and it releases the tap, so the gases always diffuses from this to here. This process is called as a spontaneous process. And जब इसका equilibrium आता है ना, and you want to take these gases in this direction, vacate this chamber and move here, and this process कभी नहीं होगा. We have to use a pump and do external work ताकि इसका process इस तरफ जाना है. Understand? And second law of thermodynamics का application, spontaneity. Spontaneity mainly depends on two processes, either energy and entropy, right beta? And the tendency, why the process always try to be spontaneous. इसका tendency to attain minimum energy by virtue of nature. Energy and stability are inversely proportional. So always a system want to attain its minimum energy so that it will have the maximum stability, and also tendency to have maximum randomness, and these two are given as a unified version. So mainly exothermic reaction is believed, I said it is believed to occur readily and spontaneously. If that is the case, melting of ice is an endothermic process and it is a spontaneous, but it is a heat endothermic process. How come it is? So it all depends upon the other cases. Some endothermic reactions are also found to be spontaneous because that is the example of melting of one ice, you know. And criteria which decide either this or dono ka hi. That is what is given as criteria of spontaneity. So, tendency to have a minimum energy, tendency to have a maximum randomness, and the result of these two tendencies together is going to decide the overall direction and the criteria of spontaneity, my dear children, that is given by Gibbs free energy change, that is the overall driving force of a process. That could be a physical process, that could be a chemical process, and that is actually Gibbs free energy. It is the measure the capacity to do the useful work, and the decrease of some value of a system, some value of energy of a system, and that magnitude of the value actually used for the work done. सो जो सिस्टम का जो एनर्जी आता है ना, सो दैट एनर्जी जिस वर्क डन में काम करता चलता है. सो यू हैव टू टाइप्स ऑफ एनर्जीज. सो यूजफुल वर्क and not useful work, and that is given as relation between that Gibbs free energy, enthalpy and temperature is given with the entropy. Delta G is equal to delta H minus T delta S, that is what is called as Gibbs free energy change. That we'll discuss. Yes, of course, delta G is equal to delta H minus T delta S. Sarika Singh. And change in Gibbs free energy change delta G. Delta H is equal to change in enthalpy, and T is the temperature, and S is going to be entropy change. Delta S is going to be entropy change. ये क्या बोलना चाहता हूँ? Okay. Hope you're understanding this. Sarika and Priyanshu, Sangram, Abhishek Raj, Suresh Kumar, Jitender, Sarika, yes, are you there, right? That's good. Now, effect of temperature and spontaneity of criteria of a reaction. That's very important. So, if delta H is a negative, okay, delta H is going to be positive. So the criteria of spontaneity, इसमें एक चीज बोलना चाहता हूँ, delta G is equal to negative, that process is said to be spontaneous. If delta G is positive, the process is called as a non-spontaneous. If delta G is going to be 0, that is system is said to be equilibrium. System is said to be at equilibrium. Abhishek Raj, right? That's good. Now, if you see, if delta G is a negative, delta S is a positive. If you put delta G is equal to delta H minus T delta S, ताकि इसको मिलेगा delta G is negative. जब डेल्टा जी नेगेटिव आता है, इट इज गोइंग टू बी स्पॉन्टेनियस. समझ में आ रहा है क्या? एंड हियर यू कैन सी, अगर डेल्टा H इज इक्वल टू नेगेटिव, डेल्टा G H S इज इक्वल नेगेटिव, एंड इट इज गोइंग टू बी नेगेटिव कब है? टेम्परेचर का डिपेंडेंट में नेगेटिव होता है स्पॉन्टेनियस का. ओके, वेरी गुड. नाउ लेट्स सी, delta H negative, so I would say these are all exo and these are all endo. So जब endothermic है, exothermic है, that is a problem. Negative and negative, it is going to be always positive, non-spontaneous at high temperature. You can change the temperature, make it, it is going to be spontaneous by changing low temperature and high temperature. That is the important parameter between these two. So thermodynamics you study like this, and let us talk about the endothermic process. For the endothermic process, if delta H is going to be positive, अगर इसका कॉम्बिनेशन में ये भी पॉजिटिव होता है एंड इट इज गोइंग टू बी नेगेटिव स्पॉन्टेनियस ओनली एट हाई टेम्परेचर। जब आप इसका डेल्टा H पॉजिटिव मान लो एंड नेगेटिव मान लो, ये वाला हमेशा पॉजिटिव हो गया, जब कभी रिएक्शन स्पॉन्टेनियस नहीं होगा। ऑल टेम्परेचर्स इट इज गोइंग टू बी नॉन स्पॉन्टेनियस। So based on this, my dear children, NEET examination में not only NEET, other medical and other competitive examination, you have a question based on this. अगर कुछ डाउट है ना तो आप पूछ सकते हैं, ठीक है। जल्दी इसका न्यूमेरिकल्स तैयार है अभिषेक, न्यूमेरिकल्स लिख सकते हैं। Okay, so if that is the case, so let's join with numericals. So it is a more than 2 hour session. Okay, my dear children, if you are okay, and would you like to have a short break so that other part of the thermodynamics we can discuss? Just a short break, Abhishek and Sarika and Sangram, Jitender. Yeah. So it is time for a short break, my dear children, short break. Okay, so I just want to discuss a timer over here. Okay, let me give you, I don't know how they do. So let's come and meet after 5 minutes. Okay. Hi students, welcome back. So the timer is over. So let's discuss about our actual context. Yes, it is. Stay tuned. Geetanjali, can you all able to hear me? You all able to hear me? Just give me a thumbs up. And Abhishek Raj, Sarika and Jitender, Priyanshu, Sarthak, Geetanjali. So is my voice is okay? Yes, it is. Now let us go ahead. Yes. Now Gibbs free energy criteria of spontaneity, delta S is equal to delta S plus surroundings. And if the heat QP is lost by the surroundings and gained by the system, then delta S is equal to minus, because lost it is given as lost. Okay. So whenever it is given as a lost, see this key point, therefore it is coming to be negative. Are you getting or not? And also, if where the temperature T is the temperature at which the heat change occurs, so but QP is equal to delta H system. So say this is equation number 1, this is equation number 2, and you can see the criteria of spontaneity may, therefore delta S surrounding system lose and system surroundings delta H system by T, and substituting this equation 1 in the 3, you are going to see delta S total is equal to delta S system minus delta H system, that is equal to 4. And let us derive this with 5 here now, multiplying with 4 with T, you are going to get delta S, T delta S total is equal to T delta S system minus delta H system is equal to the 5th equation here, and T delta S total is equal to delta G system. Since delta G is equal to delta H minus T delta S, so delta G system is equal to minus T delta S total. Suresh, hi, I was actually calling your name, okay, but you are not there, you came late, you are watching the recordings now. And if the delta S total is positive, so what happened, delta G system will be negative and the process is going to be spontaneous. And the reverse, if the delta S total is negative and delta G system is positive, then the process is not at all spontaneous. We leave about delta S and delta H. Delta G is the point of contact to say the process is spontaneous or non-spontaneous. If delta G is equal to 0 and delta G is greater than 0 and delta G is less than 0. Delta G is 0, equilibrium delta is greater than 0, it is non-spontaneous, delta G is going to be less than 0 is going to be process is spontaneous. And you can say if the delta S total is 0, equilibrium, delta G system is also 0, the process is said to be equilibrium. Understand? Clear? And you can say at equilibrium X plus Y reversibly gives rise W plus Z. Delta H is ka positive diya. Okay, the process is spontaneous in the forward direction. The corresponding sign of delta G and delta S should be. You tell me, Suresh. It's a question. Abhishek Raj, it's a question. NEET examination, how you studied doesn't matter. How you solve a question does matter, right? How you solve does matter. It is going to be 2, delta G negative hona chahiye, delta S positive hona chahiye. So like that questions are there, we will discuss some questions, okay. After some time, let me complete the concepts, okay. Let me talk about thermochemical equation. Thermochemical equation, because it is 2-hour session in one shot. Yeah, in one shot everything we have to discuss, okay. So thermochemical equation. So thermochemical equation should have, it is a thermochemical equation is a chemical equation. It is clearly mentions how much heat is lost or how much heat is gained. So the criteria of the characteristic of the thermochemical equation should contain these parameters. it should be a balanced chemical equation. So is my voice is low? So check your internet connection, okay? And delta H of the reaction should be mentioned, okay? And its physical state of the reactants and the product should be mentioned, and also if any allotropes are there, it should be mentioned. So like a graphite, carbon graphite plus oxygen gas gives us carbon dioxide gas, so that there is a enthalpy change minus 393.5 kilojoules. So this much is given minus 20, it is showing that negative value indicates it is a exothermic process. And you can see more examples like this, HCl plus NH3 minus 176, the formation of ammonium chloride. SO2 plus O2 gives us SO3, delta H is equal to minus 1. Never by heart these values. Always the question paper is going to take care of you, right? And so let's talk about the various definitions. Heat of a reaction, enthalpy change of a reaction. The enthalpy change when all the reactants are converted into the products as shown by the chemical reaction is called as enthalpy of a reaction, okay? So if this enthalpy of a reaction is measured at 298 Kelvin, where is this? 298 Kelvin and 298 Kelvin and 1 atmospheric pressure, it is said to be standard enthalpy of reaction, or stands for reaction, okay? So you can say that is given as delta H is equal to sum of the enthalpies of the products minus sum of the enthalpy of the reactants. If delta H is going to be positive, it is going to be endothermic. Delta H is a negative, it is going to be exothermic, okay? And heat of reaction is of two types. Exothermic reactions we discussed. The reactions which loses heat is called as exothermic reactions. For that, delta H is going to be negative. And endothermic reactions, I want to say the reaction in which the heat is absorbed is called as endothermic reaction. So for that endothermic reaction, delta H is always a positive value. Are you getting on or clear? Fine. And I just want to say enthalpy change in the standard condition, जब आप 298 Kelvin और 25 degree centigrade 1 atm ले सकते हैं ना, that enthalpy change at these conditions is said to be standard enthalpy change of a reaction, and that is denoted by this. So let us focus on the technical terminologies in this chemistry, thermodynamics, especially thermochemical equations. सिर्फ definition इस्तेमाल करके आप questions solve कर सकते हैं, okay? Technical definitions are very important, okay? Clear? Any doubt? So let's see various types of enthalpies of reactions. Various types of enthalpy of reactions. Now, standard enthalpy change of reaction depends on the various factors. So these various factors can give you multiple choice questions for the NEET examination. What are these various factors? There are 6 factors. So which of the following depends on the standard enthalpy? Depends on, okay? So here you can see it is based on the heat capacity, it is based on the temperature, it is based on the physical states, it is based on the concentration of the solutions used, it is based on the pressure and the volume, and it is based on the stoichiometry. That's very important. Okay, let's talk about the amount of heat evolved or absorbed when 1 mole of a compound is formed from its element is called enthalpy of formation. At standard state, you can say it is called as enthalpy of formation like this. Okay, and in the thermochemistry, if thermochemistry you can say is आपको काम आ जाएगा thermochemistry handle करने के लिए कुछ methods आता है. Okay, if and say if A plus B gives rise C डेल्टा H मान लो इसका माइनस x किलो जूल होगा. ओके अगर आप ये रिएक्शन उल्टा लिखना चाहता हो तो क्या होगा? उल्टा लिखना चाहता हूं अभिषेक राज, मेरा आवाज सुनाई दे रहे नहीं? So if the reaction is given in the reverse way, C gives rise to A plus B, है ना? C gives rise to A plus B. So ताकि इसका डेल्टा H वैल्यू प्लस x किलो जूल होगा. Okay, with reference to this, you want to just multiply this reaction. Okay, let us say, let if 2A plus 2B gives rise to C, so delta H is equal to minus 2x किलोजूल होगा. समझ में आ रहा है क्या? समझ में आ रहा है क्या? Clear? Now, if half A plus half B gives rise half C, then delta H is going to be minus half x kilojoules. If you know this law of, this is actually laws of chemical thermodynamics. समझे बेटा? And after this you can say Hess law of constant heat of summation. Super slides are there. आगे आपका super awesome slides are available. Okay, just make a note of this, everybody. Just make of this, everybody. Right. So at standard state, it's called a standard enthalpy of formation that I already mentioned. Enthalpy of formation may be positive or maybe negative, but standard enthalpy of formation could be 0 for the elemental substances. You can say for the formation of ammonia of N2 plus the 3 by 2 H2 gives us NH3. It is called as minus 46.35 kilojoules is called standard enthalpy of formation of ammonia. So it should be formation, enthalpy formation, it should be for 1 mole. ताकि इसका enthalpy of formation. You have to take formation of 1 mole of the product. Mind it, that is a key point. You want to say formation of sulfur dioxide, you have to take sulfur plus oxygen gives us sulfur dioxide. And sulfur has various allotropes, rhombic, monoclinic and other forms of allotropes. But all among allotropes, thermodynamics unified taken as a rhombic as a standard format. जैसे आपका carbon has so many allotropes, but carbon in the graphite state is going to be said to be standard state of the allotrope of carbon. समझे? And also formation of NO, you have to take the standard states, elemental states से भी होना है. Okay, you want to say carbon in the presence form of graphite, okay, plus O2 in the gaseous state gives rise CO2 in the gaseous state. This reaction says standard enthalpy of formation of carbon dioxide. That value is equal to minus 393.5 kilojoules for your information. I wanted to make this carbon dioxide by simply heating CaCO3 on heating gives rise CaO plus CO2. Okay, so this delta H is equal to some value I don't memorize. So this is not this reaction do not indicate standard enthalpy of formation of CO2. Because, can you tell me the reason why? Assertion reasoning is also very important. Why this reaction is not indicating? Because carbon dioxide is forming. Why you are not indicating this? Because you are not forming carbon dioxide from elemental state. Therefore, it is not enthalpy of formation. Okay, when the chemical reaction is given, some value is given, it is enthalpy of reaction, enthalpy of formation, enthalpy of combustion. You have to identify it. That is the key point in defining thermochemistry, thermochemical equation. Okay, and standard states of some elements. Carbon in the graphite state is taken, sulfur in the rhombic state is taken, chlorine as a chlorine gas is taken, bromine liquid, bromine is a liquid at standard state, iodine is a solid at standard state, nitrogen is a gas at standard state, hydrogen is gas, oxygen is gas, ozone is not standard state form of oxygen gas. So white phosphorus is taken, P4. This is an exception. Red phosphorus is more stable chemically than white phosphorus, but exceptionally it is taken P4. Okay, and you can say, consider the following thermochemical equation at 25 degrees centigrade, 1 atom H2 plus of Cl2 gives us HCl gas. It represents the formation of HCl at standard state. So delta H is given in the reaction. From the definition, enthalpy of reaction is equal to sum of the enthalpy of products minus sum of the enthalpy of reactants. So that products and reactants is taken, and molar enthalpies you have to consider, the temperature coefficients also you have to consider, right? And these values, if they are given, you can calculate to form the enthalpy of the reaction of formation of HCl, and that can also give you bond dissociation enthalpy also, because when this is reacted, it indicates enthalpy of reaction, but also it indicates the bond formation also. So you have to consider each and every point in this act. Okay, enthalpy of formation, you can say heat of formation upon is equal to heat of reaction upon number of moles products, and the standard enthalpy of element are assumed to be 0, and the standard enthalpy of compound is equal to the heat of formation, okay, of the products. And enthalpy of combustion, other one, heat liberated when 1 mole of a substance is completely burnt, combusted at excess of oxygen in this combustion reaction is always an exothermic reaction, my dear students. And also it means delta H is always negative in these combustion reactions. Okay, calorific value you can calculate. Calorific value is it is heat of combustion upon its molecular weight. Okay, more the calorific value, and it is greater is the fuel efficiency. That is very, very important. So a substance which is having some amount of the two substances is given, and their enthalpy of combustion value is given. You can't say which is a better fuel. You can divide these values with the molecular weight, so that which has a more calorific value gives the efficiency of the fuel. Okay, now higher the calorific value, more efficient is the fuel, and heat of combustion of ethanol is 1367. So, and carbon, it is going to be 110. Which is the better fuel? Okay, you have to divide its molecular mass or atomic mass. Okay, anyways, calorimetry, it is a very, very important, everybody. Yeah, so Suresh, is my voice is audible? So some substance is taken, some substance is subjected for complete oxidation by using a calorimeter, and the change in the temperature is measured, and the change in the temperature you can visualize as T2 minus T1 you have to calculate, and from there you can calculate calorific value or enthalpy of combustion for this heat of a reaction for this by using calorimetry. A bomb calorimeter is also called as a constant volume, constant volume calorimeter. Okay, Abhishek Raj, मेरा आवाज सुनाई दे रहा है क्या बेटा? Okay, now that can be calculated by using a formula. Delta E is equal to minus Z and theta and m by m cal. So the m stands for the molecular mass, and small m stands for the mass of the substance, and theta is called a temperature, rise in temperature in calorimeter, and the heat capacity is given as Z. You can directly use to this particular formula to calculate any kind of thermochemical calorimetry using for problems. Okay, measurement of delta H. From there you can say Q is equal to mst. Okay, C is what is called heat capacity. Okay, this heat capacity can be related to Cp and it can be related to Cv. It can be related to Cv, heat capacity at constant pressure and heat capacity at constant volume. And from there, and mass of the substance and change in the temperature, that is given as a T2 minus T1. Okay, enthalpy of solution, it's very important. This is given in NEET examination. Okay, copper sulfate and other substances will be given. You can say heat liberated or absorbed when 1 mole of substance is dissolved in large excess of water, and heat of solution can be negative or positive. So you can say magnesium sulfate solid put in the water gives us magnesium sulfate aqueous, that is given as minus 84.42, that is the heat of solution. And ammonium chloride put in the water gives us ammonium chloride aqueous. Here it is endothermic and it is exothermic. It's a super important thing. Okay, when you see this is a glass of water and ammonium chloride is added. So as this is mentioned, it is delta H is equal to plus 16.3 kilojoules. So it is going to be plus 16.3 kilojoules. It is endo. As this is endothermic process, carefully you see, when you touch this, you touch here, so you feel cold, and this is very, very important. This is very, very important. You can be getting a question from the NEET. When a substance X is dissolved in the water, okay, in a container, when observer touch this container, it feels it is cold. So enthalpy of solution is going to be endothermic or exothermic. Why? The surroundings. So the surroundings, this is a system and this is a surroundings, you can see. So when this is entering in this way, okay, surrounding ka heat is going into the system. So surroundings का temperature कम हो जाएगा and the system का temperature बढ़ते जाएगा, so that you feel it cold. Are you getting or not? Clear? It's a super important thing. Understand? Clear? That's good. And if this is the hotness, if you feel it is a cold, when you touch the container, you are going to see it is a hot. You know, that is what is called enthalpy of solution. So this is what is called heat of solution, you can say. Okay. Now we can say integral heat of solution is now, it is a stepwise. An anhydrous substance is converted into completely the hydrated form. You have to take in the various steps, that is called integral heat of solution. So HCl 10 H2O gives rise HCl dot 10 H2O, and it is giving rise to minus 69.5, that is integral heat of solution. HCl gas plus 40 HCl gives rise HCl dot 40, highly hydrated. This time it is going to be 73.1, it is integral heat of solution. And the heat liberated or absorbed when 1 mole of solute is dissolved in fixed, not excess, fixed volume of pure solvent to prepare a solution of specified concentration is called integral heat of solution. So it is a heat of solution, Jesse, but it is here, it is fixed. Understand? Clear? Just make a note of it, everybody, make a note of it. Suresh, any doubts? You please let us know if you have any doubts. Now, enthalpy of dilution. So, enthalpy of solution of HCl in water is minus 72.4 kilojoules per mole, and the dilution comes, so it should form some more diluted solution. It is integral enthalpy of solution with 10 moles of water is 69.5. And also the enthalpy of dilution of HCl in 10 moles of water to 40 moles of water is called as, the difference between these two is called enthalpy of dilution. Understand? The difference in the integral heat of solution is called enthalpy of dilution. है ना? अच्छा बात है. And the change in enthalpy when a solution of containing 1 gram mole of solute is diluted from one known concentration to other known concentration is called as enthalpy of dilution. Okay, and it is very, very important. And bond enthalpy, and there are two types you can say. It is a diatomic gas, diatomic or polyatomic. That is the two types here: bond dissociation enthalpy and average bond enthalpy. So if bond dissociation enthalpy in a gaseous diatomic molecule, the enthalpy change involved in dissociation of 1 mole of covalent bonds to produce its constituent gaseous atoms is called bond dissociation enthalpy. So you are breaking 1 mole of a bond of a type is called as a bond dissociation enthalpy. If it is a diatomic, it is called enthalpy of binary, it is called as enthalpy of atomization. H2 plus H2 gives us 2 hydrogens. Okay, bond dissociation enthalpy of hydrogen, beach mein hydrogen is 435, and chlorine it is going to be 242. So of course when a bond is formed, energy is released. When the bond is broken, energy is dissociated, energy is incorporated. And bond is broken endothermic, bond is formed, it is an exothermic. Okay, and you can say bond enthalpy, average bond enthalpy. So average bond enthalpy is the average of the each and every bond. So this is, I want to say, so CH bond enthalpies, I just want to say, let us make this methane. Let this bond value is A kilojoules mole, B kilojoules, C kilojoules, D kilojoules. Average carbon to hydrogen bond energy is going to be A plus B plus C plus D by 4, because 4 bonds you are breaking. That's what we measured here. First bond is broken, it is plus 427. Second bond is broken, so 439. They are not exactly the same. Third bond is broken, 452. And fourth bond is broken, 347. Experimentally these values are made. Okay, so the average value you are going to see. Hence, every CH bond of CH4 has bond dissociation enthalpy. The value is different, mind it, you need to understand, because bond is going to change its strength when it is removed one and one. Therefore, you can say the average bond dissociation energy is going to be sum of the A plus B plus C plus D and number of bonds 4 is going to be, that is the average bond 416 is coming. Understand? So, moving ahead, enthalpy of atomization. So, the amount of heat required to dissociate 1 mole of pure substance into constituent gaseous atoms is called enthalpy of atomization, where you can say sodium, which is a solid and it is going to be in the gaseous state, hydrogen, which is a bonded molecule, and the gaseous atoms are the products, तभी इसका enthalpy of atomization होना. Enthalpy of atomization is also always endothermic process, and that is CH4 plus C plus 4 hydrogens, it is going to be 1665 is the enthalpy of atomization. Fine. Now, enthalpy of hydration, enthalpy of solution अलग है, enthalpy of hydration अलग है. So, the enthalpy change when 1 mole of anhydrous salt combine its required number of water molecule to form its hydrated form is called as enthalpy of hydration. So, the definition technically we are giving gives a lot of impact. Mohammad Rehan, always negative. Here, you can say, for example, heat of hydration of copper sulfate is minus 78.2. Okay, hi Mohammad Rehan, how are you? First you tell me how you are doing. So, last couple of classes I couldn't see you in the class. So, कैसा कर रहे हैं? गीता अंजलि देशपांडे, अभिषेक राज, सुरेश, सारिका सिंह. Okay, talking about this, when copper sulfate, which is a solid, which is actually white in color, when you just expose to air, it absorbs water molecule around it. Spontaneously, it is going to give us a blue color crystals. ठीक है? So, this is what is called enthalpy of hydration. इसका value 78.2 होना चाहिए. And also, enthalpy of phase transition, solids to gas, it is called as a sublimation. Okay, and enthalpy of allotropic transition, sulfur rhombic is sulfur monoclinic है, and you can use these definitions to solve questions from the Hess law of constant heat of summation. I am coming to present you that after completion of this. This is what is called enthalpy of sublimation is equal to the sum of enthalpy of fusion and enthalpy of evaporation. Hey Vedant, hi, how are you? And also you can see enthalpy of ionizations and aqueous solutions. These are the definitions you can go with. Going with that, fine. Let us start with enthalpy changes Hess law. Yes, super. मेरा favorite है. Yeah, मेरा favorite है. So this law stands during a process. बड़े ना मेरा आवाज इतना ठीक नहीं चल रहा है क्या? मोहम्मद रेहान, Mohammed Rehan, is my voice is fine? I'll change my mic. Wait a minute. उसका बैटरी कम होगा तो so is my voice is okay now? Is my voice is okay now? Is my voice is okay? Yeah, that's good. So a reaction may be taking place in a single step or a multiple step. The reaction heat of a reaction is going to be same. Let us say A is changing to D. So delta H, and A is taking to B, B is taking to C, C is taking to D. So this is delta H1 and delta H2 and delta H3. It want to say delta H is equal to delta H1 plus delta H2 plus delta H3. So the heat of a reaction is same whether it takes place in a single step or a multiple steps. Okay, let's have some kinds of examples here. These are all the applications. I'll tell you by using Hess Law application. अच्छा तरफ examples दे दिया. Now let us say carbon plus oxygen gives rise carbon dioxide. This is a root one. है ना? Everybody is saying these things are very important and good examples as well. You can get carbon dioxide in another route also. Okay, so I wanted to say carbon gives rise, पहले कार्बन मोनोऑक्साइड देते हैं, ये कार्बन मोनोऑक्साइड ऑक्सीजन पकड़ के कार्बन डाइऑक्साइड दे सकते हैं. So this is the step 1 and this is the step 2 and जैसे आपका रूट 1 में जितने एनर्जी ट्रांसैक्शन किया जाएगा that is equal to the energy transaction between this step 1 and route 2 plus step 2 in the route 2. ये दोनों मैग्नीट्यूड बराबर होता है. देखो, so C plus O2 gives rise. So CO2, experimentally this value is minus 393.5. Okay, now C plus half O2 gives rise. CO इसका वैल्यू minus 1105.5 and CO plus half O2 gives rise minus 283.5. So this is the root 1 and this is the root 2. Sum of the values of the root 1 and root 2 दोनों वैल्यू बराबर दिख रहे हैं, है ना? This is going to give you the exact information about the Hess law of constant heat of summation. Understand? Clear? Now let's talk about the application of Hess law. Fe2O3 plus NH3 gives rise FeO plus H2O plus N2. This is the reaction. That reaction is called enthalpy of reaction. Right? Now let us see, this is a single step, a direct step. A direct step में थोड़ा सा indirect भी जाना. Yes. So Fe plus 4.5 O2 plus N2 and 3H2 and these two are going to give you. And arrows must show the direction of the reactions according to the data we are given. So we have to collect the data and understand the data. In this case, we have delta H of data, so we are making the compounds from the elemental state. Elemental state का जो values हमको पता है, let us see how to do that. So in this, first you see Fe2O3 plus NH3 gives rise FeO plus H2O plus N2. Stoichiometry balance करना कौन सा coefficient में, that is also very important, my dear children. Now in this is the root 1 and this is the root 2. In this root 2 Fe plus O2 plus N2 plus H2. So these are N2 H2 पकड़ना and these two are Fe and O2 पकड़ना. So for that let us see. So that value experimentally it is collected as 3 is the quotient and minus 824 and 2 is the quotient minus 46. So these values will be given in the examination questions. And coming to this value, 6 is the value and 6 is this value will be given and 3 is the value, this value will be given, understand? And let us manipulate this green color values and pink color values. And doing so, you are going to get Fe2O3 plus NH3, whose value we know that 3 into 824 and 2 into 46. Because reaction in this way it is going on a positive होना चाहिए. Okay. Now we got it Fe plus 4.5 O2 plus N2 plus 3H2. So Hess law different way I am telling you. और 6 Fe plus 4.5 O2 plus N2 plus 3H2 दोनों बराबर है. Now when they combine now, it is going to give us FeO, H2O and N2. इसमें I don't want Fe from there and FeO from there. So I just want to use the red values. 4 into minus 266 product ka, and 3 into H2, 286. Okay, why? These values are not taken. Enthalpy of formation of this is 0. Okay, and you can say, and put these values, you are going to get plus 110 on algebraic sum. Okay, you just go through this. Hess law of constant heat of summation. Abhishek, any doubt? Vedant, Suresh Kumar, Mohammad Rehan. Mohammad Rehan, any doubts? Now let us discuss one more question. Given the following data, calculate the enthalpy change in the reactions. Very important. Very, very important. So this is the equation. The acetaldehyde plus hydrogen gives rise ethyl alcohol. Hai? So substance here, acetaldehyde, enthalpy of combustion value is given, and hydrogen enthalpy of combustion value is given, and ethanol enthalpy of combustion value is given. Let us take this combustion values. Let us take this combustion value and we'll calculate the enthalpy. Desired reaction में clarity रहना है. अब कौन सा equation का calculate करना चाहता हूँ. Okay, so that is the target equation you need to know. Okay, let us talk about this target equation here. So here CH3CHO plus H2 gives us CH3CH2OH. So this is the step 1, this is called enthalpy of reaction. In that, first let us go with enthalpy combustion reaction. It is going to give you CO2 and it is going to give you H2O and it is also CO2 and H2O. So you just take this into the consideration. Arrows must show the direction of the reactions according to the data given. Fine. And in this case we have enthalpy of combustion data. So we are burning the substance this and this to make carbon dioxide and water. So carbon dioxide and water values can give you the actual calculation. Let's see. So here CH3CHO, CO2 and H2O. So it is going to give you minus 1167 minus 286. So combustion, it is exothermic. And CH3CH2OH minus 1367 is given. That is the values here given, na? This value and this value. I am using that value 286. So these are the values. Are you getting or not? So let us manipulate these values and let us calculate this. When you talk about acetaldehyde plus H2O gives rise to CO2 and H2O, and you are going to see minus 1167 minus 286, right? And carbon dioxide and H2O gives rise this much. It gives rise, it's a common, in this direction negative, na? In this direction positive. So it is going to 1367. So sum of this and this is going to be your answer. It is going to be 86 kilojoules. See how simple this Hess law, you are really going to enjoy to solve this Hess law of constant heat of summation. Are you getting or not? Any doubt? So now here enthalpy, calculate the enthalpy change in the formation of butane. in the formation of butane. What is the enthalpy of formation of butane? You need to know, right? So, given that enthalpy of combustion of hydrogen is given minus 286, enthalpy of combustion of carbon in the solid, मान लो ये graphite का है 394 minus is given, and enthalpy of combustion of C4H10 is given as a minus 280, 2877 is given. आपका चाहिए given reaction इसका, the method I have given you, use it and solve it. A question for you. It's a question for you. Come on. It's a question for you. Come on, everybody. You can solve it. Otherwise, I will make you to solve. Just take 2 minutes to solve this. Should have lot of patience to do this. And these are the actual methods you just see. Yes. So arrows must show the direction of the reactions according to the data given. That is the key point. And in this case, what is the case, you need to check it. Okay. So take this reference. You have to come across in the two different ways, and you use this and solve this question. बच्चों, ये क्वेश्चन आपका है, मैं करना, मैं करना. So what is the answer for this question? Abhishek Raj, Vedant, Mohammad Rehan, Suresh Kumar. Okay, so let me solve this question. It is going to be, carefully see, carbon plus 5 hydrogens, 4 carbon, 5 hydrogens gives rise C4H10, right? And this is the enthalpy of formation. And given data, carbon and hydrogen on combustion, carbon dioxide, okay, and it is going to give rise water, right? Now in this 4 carbon dioxide, 394 is taken, 5 water, 286 is taken, because 286, and it is going to be 394. Now let us see, it is going to be 2877 is taken from this. So take this and make a sum. Enthalpy of formation is equal to minus 394 into 4 minus 286 into 5 and plus 2877. Why? Because in this direction we are taking reverse sign as we are reversing the direction of the arrow. Okay. So when you reverse the direction of arrow on solving, you are going to get minus 129 kilojoule per mole. Understand? So let us discuss some more things over here. Enthalpy of neutralization, काफी important चीज है. This is connected to equilibrium as well. Okay. So the quantity of heat released to the formation of 1 mole of water from a strong acid base and strong base in dilute solutions is called enthalpy of neutralization. Okay. So you take the heat of neutralization of any strong acid with its any strong base, its value हमेशा constant रहता है, minus 57.3. Okay. So it could be any strong acid or any strong base. If it is a weak acid or a weak base, or a weak acid and a strong base, or a strong acid and a weak base, its value is going to be less than 57.3 kilojoules. And based on that, you have to take the enthalpy of neutralization is merely the formation of 1 mole of water from aqueous H plus and aqueous OH minus. Okay, so let us say the reaction H3O plus OH minus gives rise H2O liquid involves the formation of one water molecule only, because 1 H3O plus means 1 H plus and it's surrounded by a water molecule. So that heat of neutralization delta H is given as minus 57.3 or minus 13.7 kilojoule per mole. And you can say जब आपका H2SO4 KOH gives us K2SO4 H2O and it is going to give plus 114.6. ये ऐसे कैसे? Now because let us say HCl plus KOH gives rise KCl plus H2O and delta H is equal to minus 57.3. But here H2SO4 gives rise 2H plus and 2 KOH gives rise 2OH minus should gives rise 2H2O. So इसी का कारण आपका delta H is equal to minus 57.3 into 2 होना चाहिए आपका minus okay 114.6 kilojoules आना है. That is very important. Okay, dear students, and okay, that's a different matter. Some questions are there. So as far as the concept part is concerned, we almost every point from the thermodynamics we completed. Hope you all enjoyed today's session. It's a great marathons type session today we had, right? So covering all concepts from physical thermodynamics and chemical thermodynamics and first law, second law, Gibbs energies, entropy and spontaneity and enthalpy and everything, calorimetry and all thermochemical equations, Hess Law, everything we did it. Hi, Mahiman Singh. So everything we did it in 2 hours. So stay tuned for such type of rapid fire one shot session. One lesson is going to be completed. One chapter is going to be completed. So that we'll meet again for the next topic. We are going to talk about chemical equilibrium. So we'll do the best. Okay. All the best. Signing off, Suresh, Faculty of Chemistry, and please like and share with your friends these sessions and subscribe to Infinity Land NEET YouTube channel. Thank you. God bless you. See you again. Bye.